Hello everybody, this is BlueMarbleScience, and today we're going to take a look at a recent video from the Ballbusters channel that attempts to discredit and disprove gravity. Now some of you at least will be familiar with these guys. This particular train wreck featured John the Quantum Eraser and this fellow. That, of course, was Nathan Oakley, and as you can see, the mere mention of the word sphere or sphericity by Nathan is enough to evoke a psychotic episode. But as usual, Nathan's going to leave the heavy lifting to one of his posse. So Quantum Eraser is going to try and discredit Newton, Einstein, and gravity single-handedly. He even promises to take Newton to the woodshed. Let's see how that works out for him. You're going to hear Quantum Eraser commit a number of logical fallacies, so listen carefully, and I'll try to point out a few as we go.
All right, well, we're going to start out with Newtonian Cavendish gravity, and there's a reason why I do this, why I state both of these guys, because I don't want to lay this solely at the feet of Newton, and you're going to see that over the next couple statements that we talk about. I just think that a lot of things were attributed to him that maybe he wasn't responsible for. That's what it sounds like to me. We could talk about it after this section. But just for gravity's sake, now I'm going to take Newton to the woodshed here in a little bit, but not for gravity. But in this particular instance, and let's take a look at this. This is from a letter from Dr. Richard Bentley on February 25th, 1692. And this is about 5 years after the publishing of the Principia. And before we get into it, notice this term over here. He's already talking about a vacuum, right? In 1692. How do you know that?
That didn't take long. QE scores a red herring right out of the blocks, and wouldn't you know it, it's that spooky thing called vacuum with big old numbers like 10 to the minus 17th associated with it. Of course, that's just another way of saying practically zero, but with a lot more pizzazz. And of course, QE and Nathan thinks it makes them sound smart, but it really doesn't. It also doesn't have anything to do with gravity, but that doesn't stop QE from using it in an attempt to discredit Newton. Now, he's going to return to this later, but let's set the record straight right now. In 1650, Otto von Guericke constructed the first vacuum pump. Even the Greeks had considered the possibility of an empty space above us, but von Guericke was among the first to correctly note that in the atmosphere that surrounds us, the air density gradually declines with altitude. And you know what helped him was an Italian fellow named Torricelli, who made the first mercury barometer a few years earlier. That decreasing pressure gradient without a container, by the way, is what flat earthers can't seem to explain, along with anything else for that matter, but we'll get to that. Von Guericke concluded that there must be a vacuum between the Earth and the Moon. And you know what? He was right. So, QE.
That's a question I have. Maybe somebody can answer that question down the line, but I'd like an answer to that. However, like I said in a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, "'Tis inconceivable that inanimate, brute matter should, without mediation of something else, which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum without mediation of anything else, by and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into." This is a striking statement. Number one, he's essentially saying that the concept of gravity is absurd. And number two, if anyone is even entertaining this, then their faculty of reason should be brought into question.
Quantum Eraser has cherry-picked this paragraph. What I'm about to read is the entire fourth paragraph of the letter from Newton to Bentley, including the significant parts that Quantum Eraser left out. Now, a link to the entire letter will be in the comments. What you see highlighted in white are the sentences that were omitted. The red part is what you just saw Quantum Eraser present. And I quote, "The last clause of your second position I like very well. 'Tis inconceivable that inanimate brute matter should, without the mediation of something else which is not material, operate upon and affect other matter without mutual contact, as it must if gravitation in the sense of Epicurus be essential and inherent in it. And this is one reason why I desire you would not ascribe innate gravity to me. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else, and through which their action or force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters any competent faculty of thinking can ever fall into it. Gravity must be caused by an agent, acting constantly according to certain laws, but whether this agent be material or immaterial is a question I have left to the consideration of my readers." And one of those guys would have been Albert Einstein 200 years later. Newton wasn't having any second thoughts about the reality of gravity or its effect on matter. He knew that part of his science was correct. His concern was with the way it could act at a distance, and Einstein eventually explained that for us. You know, it really helps when you read the entire paragraph, doesn't it? Quantum Eraser, I think you just got taken to the woodshed.
From the Principia, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. That means I do not contrive a hypothesis about gravity. He says it right in the Principia. He makes no hypothesis because he can't.
We have another cherry pick. This comes from the Stanford Encyclopedia of Philosophy, and there's some editorial stuff on the front and the back of the actual quote from the Principia. So let me read this first. A third aspect of the new method, which proved most controversial at the time, was the willingness to hold questions about the mechanism through which forces affect their changes in motion and abeyance, even when the mathematical theory of the species and proportions of the forces seemed to leave no alternative but action at a distance. This aspect remained somewhat tacit in the first edition, but then in response to criticisms it received, it was made polemically explicit in the general scholium added to the end of the second edition. Now, this is what Newton wrote in the second edition of the Principia. I have not yet been able to deduce from the phenomenon the reason for these properties of gravity, and I do not feign hypotheses, for whatever is not deduced from the phenomena must be called a hypothesis, and hypotheses, whether metaphysical or physical or based on occult properties or mechanical, have no place in experimental philosophy. In this experimental philosophy, propositions are deduced from the phenomena and are made general by induction. That's where Quantum Eraser stopped, but Newton didn't stop there. He said, the impenetrability, mobility, and impetus of bodies and the laws of motion and the law of gravity have been found by this method, and it is enough that gravity should really exist and should act according to the laws that we have set forth, and should suffice for all the motions of the heavenly bodies and our sea. Now that's the entire quote. But the Encyclopedia goes on, and I'll read a little bit of this. You can read the rest of it, and a link will be in the description. During most of the 18th century, the primary challenge the Principia presented to philosophers revolved around what to make of a mathematical theory of forces in the absence of a mechanism other than action at a distance, through which these forces work. By the last decades of the century, however, little room remained for questioning whether gravity does act according to the laws that Newton had set forth and does suffice for all the motions of the heavenly bodies and our sea. In other words, it worked. No one had any further questions about the fact that it worked. The only remaining question was how it worked. So with that, Quantum Eraser, I believe you just got taken to the woodshed again. At this point, Quantum Eraser moves on to a quote from George Musser, where the phrase "snap the magic wand" is used by Mr. Musser to journalistically describe the effect Einstein had on Newton's theory of gravity. Let's listen to some of the rant.
From George Musser in Scientific American. And he's a PhD astrophysicist, by the way. Einstein created his general theory of relativity, which provides our modern understanding of gravity. We all know this. Any freshman physics student knows this. With the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. Now, I've seen this citation brought up on many occasions, and the ballers just bumble, and stumble, and make all kind of assertions regarding it. This is cut and dry, right?
Instead of discussing what Mr. Musser was actually saying, Curie just goes on a rant in an attempt to avoid the obvious. Musser was simply pointing out that Einstein's theory of general relativity and his explanation of curving of space-time provides the answer to the issue Newton himself struggled with, and that is a force acting through a distance. And while a lot of people say gravity really isn't a force at all, everyone says it acts like a force, and for most things it can be treated like a force. So I ask you the same question, Huey. What's the problem? If Newtonian physics accurately predicts the motion of celestial bodies, our oceans, our satellites, and everything we normally deal with, and it does so to incredible levels of accuracy, why are you having such a problem with it? Well, sure, we need Einstein to keep the clocks and the GPS satellites correctly synchronized. And Newton's equations won't work around black holes. But understand this, at the weak field limit, Einstein's field equations exactly reproduce the Newtonian equation for gravitational field potential. That's a fact. And for your information, big G appears in both Newton's and Einstein's equations. Really what we're talking about are two sides of the same coin. Under Newton, mass tells the gravity field what to be. The gravity field tells mass how to accelerate. Under Einstein, matter tells space-time how to curve, and space-time tells matter how to move. After Einstein's theories were published, there was a solar eclipse in 1919. And the photograph you see is the proof that Einstein was correct. The star in the center should have been where the red circle is, but it isn't. And it isn't because the gravity of the sun warped space-time. Now that experiment has been, or observation has been repeated many, many times since then. In addition to that, we've had gravity probe A, gravity probe B. I've already mentioned the GPS clocks. There's just lots and lots of proof of it and not one single thing that disproves it. So next, Quantum Eraser is going to have a major train wreck with motion and inertia. This is classic. You're really going to want to hear it.
So let's take a look at this. I pulled these both from Wiki. let's take a look. We got mass and inertia. So from Wiki, mass is both a property of a physical body and a measure of its resistance to acceleration. A change in its state of what? Motion when a net force is applied. So no problem. But rot-row, Shaggy, we look up inertia. What does it say? Inertia is the resistance of any physical object to any change in its velocity. This includes changes to the object's speed or direction of what? Motion. These two definitions are the same. You can't have one definition for two different words, people. Okay? It's non sequitur. So what do? So you gotta weasel your way out here somewhere. You should come up here and, oh, look at this. It says acceleration. And this one says velocity. QE, you don't even know what you're talking about. They're different, right? Oh, really? Velocity of an object refers to the speed in a specific direction. Velocity is nothing but the rate of change of displacement. On the other hand, acceleration is the rate of change of velocity with respect to time. And you can look at the units of measure for each of these. Acceleration is meters per second squared. Velocity is meters per second. If you're traveling at a constant rate, you have a velocity but no acceleration. If you're traveling and your rate is changing, you have velocity and acceleration. That's lovely. But you know what? Who really cares? This is the compelling factor in the matter. If something is accelerating, does it have motion? Yeah. If something has velocity, does it have motion? Yeah. I mean, this is an ongoing, unmitigated train wreck of a disaster. These two definitions are the same. And anyone can see that. So stop your weaseling.
This argument is just silly. What QE is trying to do is make it seem like we don't know what mass is. And what he's doing in this particular case is what we call a false equivalence. Now, he's doing this for a reason. He's going to use this argument later when he starts talking about Einstein. So let's straighten this out first. Take the mass definition that he has here and simply read it this way. Mass is both a property of a physical body and a measure of its inertia. There. Does that clear it up for you? Quantum Eraser, you know what's next.
Here's the next one. Here's the next train wreck. Now we got even more definitions. So the definition of mass number 2 from New York University. Mass is a measurement of the amount of matter something contains, right? Ruh-roh, Shaggy. The mole became part of the International System of Units in 1971. Currently, it is defined as the amount of substance that contains as many entities as there are in 12 kilograms or 0.12 whatever of carbon-12.
Yeah, Nathan had that same problem trying to convert meters to kilometers. A mole is the amount of a chemical substance that contains 6.02 times 10 to the 23rd particles, like atoms or molecules. That's Avogadro's number, and any kid in high school science would know what that is. You're only ever going to see it used in chemistry or chemical engineering or maybe medicine. And stop making it sound like we're confused and this is something new. The concept of a mole has been around since the 1700s. And by the way, these fish are starting to stink. Just when you thought it couldn't get any worse, it gets worse.
Since we pummeled Newton, we don't want to give all the pummeling to him. Let's go to Einstein, our favorite guy. I think you were compared to him a couple weeks ago. So I guess he's your buddy. Let's go ahead and take the most famous equation, right? Hands down, everyone. You'd probably ask anybody, and they'd at least seen this before, right? E equals mc squared. Well, number one, this is horse pucky. Number two, equations can't explain anything. At best, they can only describe. This particular equation is a fairy tale. And you can ask, if you ask any mathematician, they're going to tell you each variable in the equation, in any equation, must be defined rigorously. Everyone knows this. So, A, this was my questions when this was brought up. A, define energy, or define E, that's energy. B, define mass, and it's not volume times density. Listen, if I ask for a definition, I don't want an equation, right? If I ask somebody what a banana is, they're not giving me an equation back, right? And define C, the speed of light. So for A, let's go to Richard Feynman, Nobel laureate physics, from the Feynman lectures at Caltech in regards to energy. It is important to realize that in physics today, we have no knowledge of what energy is. You're not starting off too well. B, mass. Do I really need to go through this one again? I don't think so. And C, the speed of light is merely a convention that we've agreed upon. So this is a train wreck. This train wreck, people.
That entire diatribe amounted to a hand wave dismissal, and normally hand wave dismissals don't deserve responses. But in this case, I'll give you one. You wanted definitions for the units used in Einstein's equation. Here they are. Energy is the quantitative property that must be transferred to an object to do work on it or to heat it. It's measured in joules. The units are kilogram meter squared per second squared. Mass is simply the amount of matter contained in an object. It's measured in kilograms. The speed of light in a vacuum is 299,792,458 meters per second. That is measured. Don't try to say it isn't. It is. From this point, Quantum Eraser goes on another rant to do with time dilation, which he clearly doesn't understand, and then tries to drag quantum mechanics into all of this. I'll tell you what, we'll see you back here to wrap this up in just a minute.
So, relativity, special relativity and general relativity, via different mechanisms, speed versus gravity, can dilate, bend, or warp time. I want some of the shrooms you guys are smoking. Number one, primary school falsification. Time is a conceptual relationship between two motions. Specifically, it's based on an alleged single rotation of the Earth on its axis in respect to the sun, a day. Time is a concept. It's non-physical. It is without chemical formula, structure, charge, mass, momentum, or spin. No millielectron volts, kcals, or kilojoules. No dimensionality or orthogonality. No direction or location. You can't put time in a jar and paint it red.
Quantum Eraser's presentation went on for the better part of 2 hours, and I eliminated a large part of the pontification that goes on that show, just in the interest of time and my own sanity, quite frankly. But boiling this down, Quantum Eraser totally failed to show a shred of evidence disproving either Newton or Einstein. Despite cherry-picking his way through quotations, making misrepresentations of statements and positions taken by other scientists, failed attempts to sell us on false equivalences, and a plethora of straw men and red herrings, his only argument is a hand-wave dismissal of proven science. I'm sorry, QE. It just doesn't work like that. You're going to have to come with something better. So if that's all you got, I'd say you're busted. Hey, thanks for watching, folks. Please hit the like and subscribe on your way out, and we'll see you on the next one. Now, Curie, get over here. We ain't done yet. Damn it, Curie. Stop running. Curie, get over here.